yeah, so this is Fabian. It has a simple web UI. I say simple. This allows you to manage benchmark runs, but it also has available in it command line utilities. So you can start runs, stop runs, kill them, check progress. I added an enhancement to the command line utility to also notify you when the run's finished. So there's feedback loop there. What we're going to do is quickly check that things are deployed properly. Yeah, that's great. So let's start our server up. Right. Okay. Fine. So quickly check the application is deployed, running, and before we start benchmarking, we're just going to process one order. So that what I'm going to do next is to show you, just to load up the JBoss CLI. There's a GUI utility which allows you to inspect your running application server. So this order here will have generated some statistics on a couple of the components, probably EJB and the servlets. We're going to take a look at that now. So there you go. Start that up. Right. There's a few things out of the box. WildFly. One of the things which my team we had pushed through was to make sure that out of the box the statistics are not generated. That's finally come to fruition. So anyone running the system, you're going to have to turn on statistics at the different component subsystems. I'll show you a couple of places if you're interested in where they are. So in Undertow there is an attribute here, okay, and there is another one in the EJB subsystem, which is here, all the way at the bottom, statistics enabled and true. Okay, so you need to add those to the elements for the EJB subsystem and attributes of the Undertow subsystem. The JCA as well has its own peculiarities. That needs to have things labelled. Is it turned on? Well, we'll find out. Okay. Going back to the CLI, the GUI here. There's enough configuration files here. These things, if you can also configure this if you forgot to turn it on, configure it in the file. You can also use the CLI to turn on the attributes, and that will then save it for future use. But I'm not going to show you that because I can't remember how to do it. Some people can. Probably some of the guys over the back of the room there probably can. JBoss CLI masters. All right. Okay. Yeah. So. Okay. Let's look at some of the components. So I've got my application deployed here. Order manager. That's the application. Open this up. And it will show you two menus. So WAR archive and EJB archive. So open these up. Let's look at the EJB subsystem. And there's two particular beans, one which does orders, order manager. So that one there, it's got a load of attributes on it. Okay, it's quite useful. We'll probably look at wait time. That's the one which keep an eye on. and there is another one which is order inquiry bean, this one here. That's a state of session bean. So I hit that link. Okay, that should populate this. This is quite useful when you're trying to hunt down where exactly your components are in the application server. There's nothing more mystifying than seeing the command prompt sometimes. So this, you drill down to select your components and copy this command here, that text. And that allows you to then query using the CLI quickly, build up a command, which I have one here. And for particular things like the order inquiry bean, copy that with ls at the very beginning. Alright, that does that, and then another one with this, with a stateful session, stateful.
Two LS's.
Pardon?
You've got two LS's.
That's all I have. Thank you. Here, quickly building up a query to dump out metrics on the command line, quick and easy. So you're seeing particular things like methods on your bean, execution times, the invocation, number of invocations, and the wait time. That's quite useful. So not only that, that's a breakdown by method, and then there's another attribute here, which is the sum of all the wait time for all those methods. That's two beans, a servlet, and we also want to have a look at the connection pool. So, GPA, this is the persistence unit, which has okay metrics, but they're not particularly useful, I find. The more useful metrics to collect are the subsystem for JCA, data sources. That's what I'm looking for. There we go. I was going mad. So I've configured data source. Yeah, we should have pools. Yeah, here we go. This is statistics on the pool. So we get a breakdown of in-use count, created count, all sorts of lovely things. There are people who do this all the time, but we want to get a dump of that as well. So I'm going to add that as an additional thing to query. I'm just going to try it to make sure that we're getting more than one yes. Okay. Great. Okay, let's run benchmark. So this UI, these controls are part of the benchmark driver that you would construct. Different tabs for different things you want to, information you need to configure on your systems. How much load, how long it lasts. So in Flayban and some other benchmarking tools, you can set up a ramp-up time, steady state, and a ramp-down time. It's quite useful because you will want to use the ramp-up time to warm up the caches, warm up the operating system cache, the database caches, the various things that need to be populated with data to bring it all closer to, and also on the cores, the CPUs. So ramp-up time is quite useful, but you don't want actually that period of time to be measured. So steady state is the time where things start to get measured and doesn't. And then ramp down time is there just to kind of keep the system running while you're still, you finish measuring, but you don't want it to collapse at the end of your measurement run. You want it to kind of ramp down nice and gracefully. There's a few other things here. This is the driver which I've implemented beforehand, and some details of the application server and the database. So this system will, not on this particular laptop, on other systems that we have, we've got benchmarks set up to reload databases, all those sorts of things. Useful things which need to be done. It gets very laborious when doing performance testing. So you can quickly turn on and off those particular features. Reloading, starting up the database. So I'm going to start us off now at a low rate. Yeah, okay, let's just do low rate because I've contrived examples. So do some things. And I mentioned a tool called dstat. There it is. Quickly, it gives you a breakdown second by second. CPU, disk activity, network activity, paging in the system, and system interrupts and context switches. And it's coloured as well, which is nice. So we can see very quickly that the system is doing stuff. But we also want to check it also generates some log files. So there's a log file to give you a progress of what it's doing during the run. But it also generates the runtime statistics as well. So looking at this, we can quickly see activity on the system, and we've got absolutely no throughput, and we've got errors. Okay, so checking for silly mistakes. So I'm going to have a look at the log file to see what schoolboy error I've done. So we've got, there we go. So I've configured the system to the URL here, to that, which is not what it should be. Okay, so we're going to kill the run. So that'll kill off all the Java processes. There'll be one for each agent. So you can craft the benchmark run to have multiple agents, and those will be doing operations. You may want to have a manufacturing operation and a website operation subsystem. You may want to have multiple JVMs running load at the same time, so you can configure how many JVM threads. So I've killed the run here, and I'm going to just change the configuration file. And kick it off again. Let's have a look at that. looking back at this, we were seeing that's when the system was idle and activity came along, but not very much. So let's see if there's anything different this time. Okay. Here we go. We see it starting up its various services. There's some more activity here. Interesting to see. So it started up, and there's not a lot of errors in the logs. We start to see here throughput, statistics of our run, which is quite useful to see, and then response times for the various operations. Okay. The benchmarking tool is quite useful if, well, the team I work with, we find it very useful, but it may well be overkill. You know, other tools, you just don't need this level of detail. But when you come to select a tool, it's quite useful to know what's there. So that's there. Let's start querying the statistics in the system under test. So that's come off. Okay. So inquiry bin. We've got some wait time here. Doesn't look too bad. Yeah, wait time. Okay, there's a bit of wait time there. Creating orders. In fact, more than I'd expect. So that would be an indication that on your system there's a bottleneck. Seeing you know, higher than you would expect wait time. Okay. So that was at the EJB. So what does it wait on? It'll be waiting on, because I know because I wrote the application, it'll be waiting on the JCA, so the pool. So let's have a look at the configuration for the pool, and that has pool size here, and that has okay, that's got 16. Right, I actually set this down to 2 beforehand to try and get wait times to be even higher. But I'm going to have another go at okay, so you can see the run's finished now. Yeah, so I'm going to set the pool size to 1, okay, and also I'm going to increase the amount of load on the system. Okay, so these two things should start to give us a bit more of a okay. Now, one of the things which the team does use, it finds also useful in this, is the display of prior results.
Okay.
There are certain metrics which have been pulled out, which are particularly relevant. Things like the average response time and the operation here. There are other, should be other columns, but business operations per second, those are particularly relevant as well. That's where you find out how much is processed, and the driver collects metrics on each of the different operations. So here we see average response time, max, standard deviation, and the 90th percentile. It's quite useful. When you construct your benchmark, you'll also be setting response time SLA. So that SLA will be checked at the end of the run, and you'll have a quick summary of passed and failed. See here, think time, failed. So that's quite useful to see in detail. We're going to start another run this time. We're going to scale it up a little bit more. So this is before things have really got going, and you've got wait times of 0. So we're going to see wait for activity to start kicking in here. And have a quick dump of more statistics. And cross your fingers. You're going to see some higher numbers than we did beforehand. Much happened, is there? Yeah. Okay, so it's just starting up. There we go. So we're starting to see more activity on the system. Checking for errors, response times. So that's 20 users. Let's see what the metrics say. The wait count there is variable. That was not too bad. And that's even better. There's these metrics here. Obviously not enough. I'm going to kill that run. Start. Yeah, let's go for 100.
That's right, we've changed that from 16 threads to 1 thread in the board. So the wait times come down.
Yeah, let's check the configuration file, see if it's I know, it's not, it's slightly counterintuitive, really. Any suggestions from anyone? This wasn't part of the contrived example. So,
unless your database has a concurrency issue.
Number of allowed points on the database.
Let's take a look. connections. That's your default. So the max connections are 200. Okay. So that's a good suggestion. Well, let's look at some more log files because okay, what do people say for checking for silly errors? Okay. Could not apply work.
Is the pool size of one actually viable? We need at least 2 in order to...
Could well be. Because the application will be using connections in the pool to do things at the same time, creating orders and also viewing orders as well. So with a pool size of just 1, it's not actually able to operate. Sorry.
No, I was going to say, so you're just going to have one
Yeah.
thread that's working, and then
Yeah.
you can't use another one.
Yeah.
So it's just going to buffer it.
Yeah. And so we're seeing the system bath.
Yeah.
We've got great response times.
It's like you said about 404 errors, right?
As you can see, this gets more tricky as yeah.
Would you normally check for something returned on the page in Drive to verify that it's...
Usually you kind of 200 response code.
Actually for page content, that there's a particular token or a non-error token.
Yes, I mean you can. Yes, you can craft your driver to start to parse the HTML response. Of course, that's going to have some overhead. But yeah, typically that's what you do to check for a certain number of items in a cart or a response error.
Well, even just a simple string search and return data, so not passing the full thing, but just does it contain
exactly
the link to the next page?
Particular code which is only sent when it's successful. So okay, let's get this going again. So we're going to restart our application server, shut it down, change the configuration.
Could be concurrency in the transaction.
Could be. Could be.
Possibly it needs one floating connection just.
So we're going to have, let's give ourselves 4, 8. Let's give ourselves 8 connections in the pool. The load at the we're going to push a lot of load by the driver. So we want to see things start to back up and start to see that EJB component wait for connections in the pool. We also want to make sure that there's enough bean instances. So the order manager bean, this one here, that's pool size. Yeah, let's give ourselves 20 because that would be the next bottleneck. Start it up. So let's kick this off again. Okay. things keep starting up now. So there's 2 agents in this particular benchmark driver. Each of them is started up as a JVM process. Fabian will then push out configuration to it. So that includes any libraries, and it needs to interact with the application server. So if you, say for example you're doing remote RMI calls on EGVs, you'll need your the EGV client libraries. So Fabian can push it out for you. You build when you're part of the driver application, you bundle all the libraries in there, and so then Fabian will then pass that package around to all your various machines which need to push load at the application server. It's quite handy, but it's quite full blown and involved getting it all to work. This is not the most intuitive system. Okay, we've got operations going through now. We don't have any errors. Okay, right, let's see. So we've got fairly, yeah, we've got some activity. We've got this column here, which is wait time. That's waiting on I/O, which can be invariably is disk I/O. So that'll be the database writing records to the file system. And so there, so let's do the metrics for the application server. And we have, well, fair amount of wait time there. Wait time there, which looks, oh no, that's more like it. Audible sigh of relief, yes, that's what I wanted to see. So now we've recognised something that we want to tackle. We're going to go back. We'll let this one finish. Okay, so there's a tool which we'll ignore. Fabian not only allows you to construct operations which are then pushed, fired at the application server, it can also, and those are measured, you can also build in to run at the same time background work. So if you've got other systems, for example, which would typically be running on a system, other activity, you want to create background load. Fabian allows you to build this in as well. But those are not measured in the same way, and those are not part of the final success criteria. Okay, we're seeing this little circuit here. I'm happy to ignore that, because that is a servlet which I know I wrote to clear out data. One of the things which we found is that more and more data gets added to the database, and that can start to skew response times and with more records in there. So I wrote a servlet just to clear it out. But these error messages here are just that being reported, which for the purposes of what we're doing here, I'm going to ignore. Okay. So some of the results we've got. Here we've got success counts. So this is where response codes are checked, make sure they worked. Response times, but it's the metric on the EJB which gives an indication that there's a bottleneck on the JCA pool. So we're going to change that. Let's just run that and see what final number we get for that. Is wait time. And this is on the order manager beam. Okay, so that one in particular there has this number, which I'm just going to note down. There we go. Okay, let's shut the server down. should we give it?
64.
64, okay, thank you. Right. Start her up again. Okay. So this is where we've got a timeout as well. I'd like to see. Okay, that started up. I'm going to shut it down and just clear out the logs. Okay. Start her up. All load of nothing. Have I got that right? Nothing. Let's just check the logging. Ah, set an error. Okay, let's change that. So it's useful to see something in there. Okay, that's more like it. Once that's started, we will kick off another run. Let's keep it at 20 because we want to compare the amount of time, wait time. So there's no point changing the amount of load pushed at the system and then, yeah, change one thing at a time. Yeah.
Sure, that was my slide.
Yeah, yeah, that would have me confused. You'd be here till 10 o'clock. Okay, so that will run. This web UI will also show the log file in progress. Okay, let's kill that. Get ready with that. Okay, so we can see the system is quite, very quickly see it, there's very little idle time. Very little. So on a, yeah, we're seeing this computer maxed out.
No wait time.
Well, we'll find out. Let's
All the decent times.
yeah.
Sorry, I
Yeah. There's no network activity. Well, let's see if there's something going on here. That was which one? November. So, load the log file. See what's going on. Just checking here for throughput. Yeah, we've got some operations per second. No errors. Errors at that. Yeah, response times. So that's okay. We've got stuff going through the system. It's heavily loaded. And so we're now looking at wait time. order manager bean, wait times there. Well, let's wait for this run to just finish off. Several things here. That was, yeah, so the data source, pool statistics. We can check to see whether we've got, how many are idle, how many are in use. We want to see a good, in-use count and a relatively low idle count. If we were to see kind of 50 idle, then we know we'd have too many resources allocated, and we need to rein that back in again. This is where we're kind of, not only are we providing enough resources, but we're not wishing to provide too many. So these metrics allow you to check all these sorts of things. Okay. Okay, right, so I think we've got the end of the run there. And order manager bean, we have that one there. Wait time is about the same. You look at that, yeah, that's pretty much the same. So, what does that say to you?
Compute bound?
Could be, yeah. Could well be more than the system can actually. CPU is actually.
What's the overhead of running a test framework on the same system?
Oh, there will be overhead. It can vary depending on what exactly your several things. How many operations are being pushed, what type of workflow the operations will go through. Selecting things from a cart and then placing the order. Through to how much response checking you're doing as well. So that all adds overhead.
Do you typically run these tests on your laptop as opposed to, say, setting up a bunch of EC2 VMs or something?
It would be on for performance, getting reliable performance results. You need ideally a dedicated system, and that is, when I say dedicated, I mean I'm talking about bare metal as well.
Yeah.
Otherwise, you're going to have the vagaries of your system deployed to East Coast, West Coast, Europe, and those will all give you, depending on time of day, different profiles of response times.
You just introduce some more variables where things could go wrong, or things could give you false positives.
Absolutely, yes, absolutely. So ideally you get dedicated hardware, if you can.
We run it on local VMs, but you want to have all the other VMs idle, and maybe just have
one of those.
Well, you can have the set of VMs on a single piece of hardware, but it's reproducing the same situation each time. So if your system is a database server and an app server, and you're running the test from a third box, then the 3 VMs on the same thing you can do, as long as there's nothing else in that.
Yeah, exactly. That's background work. And you ideally want the system to be not used by anyone else, and also you want to make sure that the system doesn't have little background activity, which is maintenance work, but background tasks that the platform itself is doing. So there's a tool called JHiccup. You just get that running, and it will just give you. And this is when you run it when your system's idle, and it records kind of things which are happening on the system without any activity, which give you increased response times. And those are things you should be looking at tackling to give you a really consistent, so the results you're getting are not going to be skewed, or you get strange kind of response times, and you can't fathom what's going on and why. Now, in this example, we saw that, okay, going back to this, these two numbers, it probably means that this system is overloaded in both those scenarios. So allocating more connections in the pool isn't actually going to be able to, this system won't be able to scale up, basically. On a system where you have like a dedicated database server, then you're going to be able to see this in tuners you're going to be able to get these metrics to work for you more obviously.
Well, it got it to compute bound, which is probably where you want to be.
Exactly, yeah. And that's all aspects of the system under test working on the same machine. So, yeah. Okay, so that's that example. We'll come to the end of that over there. There are, using the CLI, you can quickly get an overview of what's happening in your system. You can get the same for JMS connections as well, resources. We won't go into that. Let's go back to the presentation then. So, we use the CLI to dump out some stats. But in systems which you have not just one machine, you have multiple machines, you really want to collect and aggregate these metrics over time, so that not only yourself but other people can check those. And that data can get fed into data store, whatever type it is, doesn't matter if it's NoSQL or if it's a SQL, and then you can then derive your own statistics from that. Because what you'll find is some of those metrics that we've seen are quite primitive. So for example, the servlet statistics is the total number of requests, the total amount of response time. Well, that just increases over time. So you won't be able to kind of compare over time without, if you want to see kind of second by second, hour by hour differences in comparison, you need to have another system where you're taking those metrics, you're deriving your own, and you build up over time. You can compare what was different from the previous hour, previous period of time. With that, you start to get information. You can start to act on that information, and you can build a responsive system, which is what we're starting to see with cloud computing and dynamic and scalable systems which react to what's happening on a load, unpredicted load. So I'm not going to cover that because that probably is a whole another presentation, which I will leave to somebody else. So if you have any questions or if you have any feedback, to not just myself but to the team, this is where you can find us. We're on an IRC channel which is publicly available. It's on freenode.net. It's JBoss Perth. You'll find a few of the guys there. I'll be around the UK time, but we also have people in the States. We have people in Norway and Portugal and Czech Republic. So all smart guys. They'll be able to help you as well, not only myself. So, and then that's my email address, so you can contact me using that. So, has anyone got any questions?
It's more around the automation part of the metric collection. Do you have any tools that do it, or is there?
I mean, there are invariably people are writing at the moment tools to pull out, JBoss, querying the JBoss CLI. I think there's some development going on at the moment in WildFly to provide an API so that things can be done from a remote machine, connect to the application server itself or the domain, pull those stats out to a local environment, and then start to do something with it, like then push it into data store.
Okay, but there's nothing there at the moment, because I was recently looking at stuff to do via JMX and out into StatsD, but WildFly doesn't support JMX MBs on most things, so...
Well, you need to, yeah, I mean there's a certain number of libraries you need to put on the class path to get those JMX beans visible or actually work with them. I think that does work. There's a tool which is bundled in the bin directory, which is JConsole. I think they've written a batch file which will add all the libraries that you need to kick up the JConsole. To then, and then you can look at the beans, the MBs that way. Okay.
Those beans basically was the access to the CLI.
Thank you.
Yeah, thank you. Okay, in terms of, so people have pulled out those stats, and some of them put them into a Cassandra database because it's convenient. You can just flick a button and you just turn on the resource and you get lots there. And then, and they've also, I've seen an example, somebody then uses a rules engine to start querying that data in the Cassandra data store. And of course we've got JBoss rules, so you do that. To then start building in what the behaviour, how the system should start reacting. So do you need more servers, do you need more systems, or you're getting particular types of errors which need to be out of memory exception, for example. So something needs to be killed off and started again. So there's many different ways, and it's beyond my experience really to suggest a reliable way of building this. I mean, yeah, there's many ways to skin a cat. So that will be something you could ask the other guys on the IRC channel, but also you could go on to the WildFly channel and ask people what they are, what they would suggest, because there's people who are kind of looking at how do you kind of build this infrastructure with not just the application server, but also a data store and a rules engine, and how to make it all sing and dance. I don't know if any of the guys at the back of the room there can come up with any suggestions. They look familiar to me, so this forum, no, they're all ducking their heads. So no. There's one question there.
Oh, it's just would you consider performance part of the continuous integration environment? Because if you set that up with Jenkins or whatever, you can have some form of data collection that goes back in. So that might solve part of your collecting data if you're not dealing with it. But it also means every time you make a commit, providing you've got the resources, you're going to get a performance baseline with that.
Yeah, Jenkins is a really useful tool. Guaranteeing that you're not having load, not just in the system and the test, but also the driver as well. Yeah, you've got to kind of schedule Jenkins to make sure it's exclusive. So only
absolutely, you've dedicated hardware.
Yeah, and it's dedicated to just running certain jobs to be doing performance testing. Certainly, yes, you can build that. Building that into your kind of daily routine is invaluable, because it can help recognise regressions.
Because even if you can't deal with the data immediately, if you need to go back and see where did this change, you've got the thread.
Yeah, exactly. Yes. Any more questions from anyone? Okay, good. So there's a few things here, references I would suggest. This is a book I mentioned earlier on. That's the ISBN number. There's a tool that the team uses called Whiteman. That's a project developed by JBoss. It is, we use it over and over again in the team. It's invaluable. A smart chap called Andrew Din he is the mastermind for this tool. It allows you to do bytecode manipulation to your application, to a running VM, to one which is already running. You can inject start of an agent and apply, you basically write scripts, bytecode scripts, and send that to the agent, and that will then change the bytecode of your application to do certain things. It can do a whole host of things, but it can recognise a particular scenario. It can even construct a particular scenario that you wish to test or replicate on a system. It can coordinate threads, as in not just once, but coordinate multiple threads to do for a particular scenario, which you have the transactions team.
Trigger deadlocks.
Yeah, trigger deadlocks, throw errors, particular types of exceptions. Byteman will allow you to do this very easy, very quickly, and very unobtrusively. So you're not having to redeploy your application. You've got it running already, you write your scripts, and you just inject these things. And then you can just back it out or revert it back to what it was. The team which does support at Red Hat, they find it valuable. They get customers calling up, and those customers say, we've got this problem. So they do a lot of talking back and forwards, and the support team will say, try running this bytecode script. What it can do is done things like stack trace a particular problem, or change code slightly to do something else. It saves so much time, and it's a beautiful tool. These are the website addresses of the other tools I talked about. Gatling. I know some of the people in the team I work with, they like Gatling quite a lot. It's quite a nice API to work with. And there we go. So that's it. That's the presentation. I hope you had a good time. I hope you found it very interesting. I'm glad to see so many of you here. It's a relief. Thank you very much.